All right, guys, we are ready for part 2 of logarithmic functions, and here is where we left off. Let's take a look at the previous slide here. Having a hard time getting there. There we go, and base 10. So we talked about how a common log has a base of 10, and we have one other kind of special log here, and that's called the natural logarithm, and the natural logarithm has a base of e. Now we've seen this number before, but we haven't really talked about this number. So e is an irrational constant. It's an irrational number. It's approximately 2.71828 ... continuing forever. We have some other irrational constants like pi, which you're familiar with, and the golden ratio, square root of 2, which is Pythagoras' constant, and then we have this e. If you want to know where this e came from, what it is, what it represents, I did save a video in my playlist so you can hear a little bit of a history about this number and what's so special about this number. But this e is Euler's number, and it represents approximately 2.71828, continuing forever and ever and ever, which is why it's irrational. And the special notation for a logarithm using this number is ln. This natural logarithm is ln. So when we're looking for the log, for example, the logarithm of 4.72 to the base e, we would just write this as ln 4.72, and that's approximately 1.5518. There is a button on your calculator that allows you to find natural logs on your calculator. Again, if you want to know more about Euler's number, watch the video. It's super helpful. It tells you where this number was derived and what's so cool about this number when we're talking about functions and calculus. To write that in exponential form, we would say e to the 1.5518 power is approximately 4.72 if we were to switch that into exponential form. Don't forget, logarithms are exponents. Logarithms are exponents. Logarithms are exponents. Today, we converted between exponential and logarithmic form. They're the same thing. Logarithms just give us a way to solve for exponents that we don't know. All right, so when we have 2 to the y, x equals 2 to the y, and we want to solve for y, logarithms give us a way to do that. We can say that the log of x to the base 2 equals y. 2 to the y power equals x. All right, so logarithms help us solve for those exponents. Logarithms are exponents. So we converted between the two different forms, what they look like. We also looked at a graph of the exponential function and the logarithmic function. We evaluated logarithms of numbers. Once you put it into log form, you can just plug that into your calculator and graphed logarithmic functions. Now, we only looked at the log of 2 to the x power, but we could definitely see the general shape there, and we can then graph any other logarithmic functions that come our way. The most important thing that you need to take from this lesson is how to convert between the exponential and the logarithmic function. That's the most important thing that you need to take from this lesson, understanding the relationship between the base and the base, the exponent and the log here, and what we'll call the answer and the argument. Answer and the argument. So the base of the exponent is the base of the logarithm. The quote-unquote answer, the answer of the inverted exponential function here is the argument of the logarithmic function, and the exponent in the inverse exponential function is the logarithm of the log form, this over here. Remember, this is only when we're looking at the inverted, the inverse exponential function. inverse exponential function. The logarithm is just another way to write the inverse exponential function. All right, new information, not super hard, but very new. So make sure if you have questions, go back and watch this again until it kind of sinks in a little bit. I'll try to link some more videos that are helpful to you on YouTube. Write down any questions that you have and we'll address those next class.